In this presentation, I'll explore the definition and significance of semiconductors, the causes of semiconductor chip shortages, the critical role of Taiwan in the global semiconductor market, and potential solutions to stabilize the semiconductor chip shortage. A semiconductor is a substance that possesses certain characteristics of both conductors and insulators. Silicon is a common component of semiconductors because it conducts electricity more than an insulator like glass, but less than a pure conductor like copper or aluminum. The birth history of semiconductors can be traced back to the invention of the rectifier in 1874. Decades later, Badin and Breton at Bell Laboratories in the US invented the point contact transistor in 1947, and Shockley invented the junction transistor in 1948. In 1959, the bipolar integrated circuit was invented by Kirby of Texas Instruments and Noyce of Fairchild Semiconductors in the US. This invention had a major impact on the history of semiconductors, and it marked the dawn of the IC era. Semiconductors are the heart of billions of products, literally thanks to technological advancements in numerous areas, ranging from smartphones, computers, data centers, household appliances, laptops, tablets, smart devices, vehicles, life saving, pharmaceutical devices, ATMs, agri-tech equipment, and more. Nowadays, semiconductors are either necessary for every sector in the world or they are its primary enabler. The cornerstone of contemporary technology is the semiconductor. Semiconductors are essential parts of electronic products that drive the creation of high tech goods and services. They also play a major role in the advancement of technology and global economic growth. Semiconductors find widespread use in a wide range of industries and daily applications such as cloud computing, 5G communications, artificial intelligence, Internet of Things, healthcare, military systems, transportation, and clean energy. The importance of semiconductors can be seen in their ubiquity in our daily lives and in the inconveniences we face due to chip shortages. There are several factors that badly affected chip shortages. They include production stoppages due to supply chain disruptions during the COVID 19 pandemic, increased demand from consumers working remotely or under lockdown, rising raw material costs, and supply constraints due to geopolitical tensions and natural disasters. Regarding COVID-19 crisis, factory closures due to COVID-19 led to difficulties in semiconductor production and inventory management. Additionally, reduced flights and airport closures disrupted the smooth supply of chip deliveries. Furthermore, the shift to remote work and extended quarantines affected worker morale. According to industry analysts, the so-called 200 millimeter wafers, which are used to make lower-end circuits, show a particularly noticeable mismatch. These include integrated circuits for power management and displays, which are in limited supply right now and are needed in a variety of industries from consumer electronics to the automobile. In addition to wafer foundries, shortages or delays are also occurring in wire bonding, substrates, supplies, and testing. Also, this is inherently challenging and facing issues as it is highly complex in nature, like long fabrication cycle time and variability stochasticity. Geopolitical tensions are also among the causes of the semiconductor shortage. In 2019, Japan's export restrictions on South Korea led to difficulties in sourcing three essential chemicals like hydrogen fluoride, fluorinated polyimide, and photoresist for semiconductor manufacturing. Additionally, the trade war between the US and China, as well as the political tensions between China and Taiwan, have further exacerbated the situation. Just-in-time production techniques, which keep inventory levels low, can boost productivity and cut expenses. However, this strategy may not work well in unanticipated circumstances like COVID 19. During unexpected shortages, businesses had a tough time obtaining a sufficient supply of semiconductors because of the restricted inventory. In 2021, semiconductor supply faced significant challenges due to the AKM factory fire, the Renesas Naka factory fire and earthquake in Japan, the Texas winter storm in US, the drought in Taiwan, extreme weather conditions in Southeast Asian countries, power shortages in Germany, and power rationing measures in China. The trade war between the US and China and the onset of the COVID 19 pandemic exposed vulnerabilities in the globally concentrated semiconductor supply chain. This caused raised pricing, increased lead time, and contributed to constraints on raw materials. In response, major economies are planning to relocate semiconductor supply chains outside China or to their own countries to mitigate geopolitical risks and enhance supply chain resilience. This shift has moved the global semiconductor landscape from being highly interconnected to more regionally integrated, highlighting Taiwan's critical role in the industry. In 2022, Taiwan manufactures 63.8% of the world's semiconductors, and its production of sub-7 nanometer high-end ICs garnered the global market share of more than 70%. Taiwan's 2 nanometer process technology is the most advanced in the world, and it remains the global leader in terms of both technology and productivity. Taiwan's IC packaging and testing output value is also ranked first in the global semiconductor market with a market share of 58.6%. Moreover, Taiwan's IC design output value accounted for 20.1% of the global market, with a market share the second only to that of the United States. Without a doubt, Taiwan plays a critical role for global economic growth and technological innovation. Taiwan's total IC and IC design output value ranked the second in the world and trails only the United States. Taiwan's foundry output value ranks first in the world, while its IDM output value is fifth, following the United States, South Korea, Europe, and Japan. Additionally, Taiwan's IC packaging and testing output value is ranked first globally. In 2023, Taiwan maintained its lead across the board from 0.18 micrometers to 20 nanometer and sub 10 nanometer processes in the global IC manufacturing industry. Six Taiwanese businesses were listed in the top 10 worldwide IC packaging and testing firms in 2022. Among them was Advanced Semiconductor Engineering Technology Holdings, which held the record for the largest packaging and testing business in the world, with a roughly 30% market share. For IC packaging and testing, the top 10 players held 85% of the global market share. Taiwanese enterprises held 45% of the market share among the corporations in the list. To overcome potential future supply shortages, countries can take measures such as investing in semiconductor facilities or funding semiconductor research to increase the number of local semiconductor suppliers. For example, South Korea plans to spend $451 billion on domestic semiconductor production. Taiwan invests 100 billion US dollars to meet the increasing demand and expand its foundry in Arizona, US. Regardless of the degree risk associated with the location, one region might control more than 65% of the global market share at 50 different points in the supply chain. Each of these areas is seen as a potential single point of failure due to the possibility of disruptions from natural disasters, geopolitical unrest, closures, etc. Apple and Tesla are two businesses that handle the chip scarcity issue well. Supply chain resilience can be greatly increased by manufacturing some chips in house and having products that work with various chip types depending on availability. Semiconductor production is complex and increasing production capacity is costly and time consuming. However, the adoption of AI can streamline the manufacturing process. Additionally, inventory policies should be adjusted in the long term to include more buffer stock to prepare for emergencies. IoT has been cited as a creative solution for semiconductor shortages. Disruptions can be predicted through real-time data sharing and analysis. Furthermore, problems can be identified ahead of time and dealt with accordingly, improving the efficiency and resilience of the supply chain. Manufacturers are able to make sophisticated decisions based on collected information and use of data elements that were in siloed applications previously. End-to-end performance can be improved from IoT analytics throughout the SSC, including demand forecast, production, scheduling, and inventory control. AI can also scan for chip defects in real time, improving quality control processes. Thanks for watching my video. 시청해주셔서 감사합니다. 谢谢大家的收看。타리마카시 수다 메논통